Hello, this is Dr. Hisham Said. This video is the first part of a bigger lesson on project scheduling. And in this lesson, this video, we'll learn about the benefit of scheduling in general and why we need to have a time schedule for a project. And we will comprehend the process of developing a project schedule, including the first important step, which is developing a work breakdown structure of the project scope. So construction scheduling is a management task, and it's one of the most important management tasks besides cost estimation. And the purpose here is to set and predict the start and finish times of activities, and also kind of plan for the resource utilization for each one of these activities. Why we need to do scheduling in more detail. The benefits are, first, it's a visual representation of your knowledge about the project and on your understanding of its scope. So it's kind of helps you to understand. It helps you personally when you develop the WBS to understand the scope of the project and represent it in a visual way. So it's kind of like a mind map of the project, and mind maps are generally good to understand really what you are dealing with. And then the other thing is to maximize quality and safety of the project. So when you start scheduling, you coordinate between the work activities in a way that first they don't have a bad impact on each other in terms of quality, and they also don't put the crews and laborers that they're working in activities under safety issues. So you don't do two different tasks close to each other in the same time in the same space that they cause safety and quality issues on each other. The next thing is to improve the planning of resources. So if I need to bring a crane for installing a rooftop mechanical equipment, it will be good if the schedule tells me I need this equipment on this day and this month. So that will help in planning the resources that you have. You need to know when to bring them in. And also it makes sense to lump and do the activities together that use the same activity. So if this crane is used for another activity or another task to install the roof trusses before, so probably I will keep these activities in line or sequence together in a way that this resource, this important heavy resource kind of is utilized in the best way. And also it's good to coordinate in general between the team members. So the first thing that the owner asks for in contracts when they have a contract with a contractor is show me your schedule. So I need to know that it's feasible that you will deliver the project in the time you committed to. And also the GC communicates the schedule information with the subs to let them know that you are needed on the site in this week or these number of weeks for this project. The next benefit here is streamlining the procurement of long-term lead items. So when you have, generally in any project there is a long lead item and you have to pay attention to it. So if you have a steel structure, then it's one of the lead items because you have to do shop drawings for it, and then you have to fabricate it offsite and then ship it. So that's a long lead item. Another one is like elevators. So if you have an elevator, there is shop drawings, also fabrication. It's not like off-the-shelf item. And another one is kind of in kitchen, large commercial kitchens, there's the walk-in freezer. This is also something that's fabricated by order, so you have to make sure that shop drawings and everything fits in together before you fabricate and ship it to the site. So long lead items is one of the important reasons why you need to have a schedule. So you need like 2 months ahead to know when this equipment is needed on the site and when this part of the building or assembly need to be fabricated. Another thing is to account for environmental constraints. So like when you plan and you schedule and you find your schedule that you will do the shell of the building in the middle of the winter in the Midwest, let's say in somewhere in the Midwest, Illinois, Indiana, Wisconsin, you can do that. It's very cold. You can do that in the winter, that type of work. So you can predict that and you can actually work on changing the logic so you can do that shell work ahead of the winter, so in the winter you can work inside. Another thing is like if you do a project in Midtown in a large city where you have a carnival, and this this day, so you can account for this in the schedule and put this date in the schedule as a constraint. And finally, is generally schedule is good to synchronize the pace of everyone in the team. So there is no one super achiever while the others are struggling with their activities, because that super achiever is not helping anyone. They're just doing the work and creating inventory and waste in the project that causes actually problems more than it actually helps the project as a whole and the team. So schedules have a lot of benefits, and these are just some of them. So now how to develop schedules. Generally it's done by GC. So the GC is kind of the master coordinator in a project, and this schedule is done to coordinate between the project team and also share the information with the owner. Now how it's done, this is kind of a simplified view of the process. We will cover in this video the first step, which is defining the work, and then the other steps will be covered in the other parts or videos of this lesson. So we need to define work activities. Activities or tasks are, each one of them is a package of the project work. So it's packaged in a way that satisfies these following conditions. The first one, every activity should have a discrete continuous duration. So recognizable start and finish with no much interruption in the middle or dependency in the middle of other things. So when I do, like I say, construct a footing, not like that. Let's say rebar, doing the reinforcement of this footing. If I fabricate it, so I start fabricating the rebar, and then to put the rebar in, I have to do the formwork first. So that's a dependency in the middle, so I will have some interruption in the middle. So that's having just a rebar activity might not be a good choice. Maybe you need to split it into fabricate the rebar, so you're now dependent on the formwork to be done, and then you install the rebar. So that's one condition, is you have a discrete continuous duration for this activity. The second thing, it's measurable scope. So it should have a measurable scope that can be measured in common quantities that we have seen in the lesson on cost estimating and quantity takeoff. So when you calculate quantities, it's like volume, area, length, but you cannot like do an activity that says construct classrooms. Yes, you can measure it by room, but what does this mean really in work? Because this classroom will entail doing stud walls, plywood, mudding, painting, and every one of these have its own quantity of work. So it's something like you have to have the activity measurable in a quantity that's simple to track and can be used to track the performance of the activity. But just saying I will finish this classroom, or this activity will be just finishing classrooms, this is not up to the level of detail of quantities that you would like to track and control your progress and performance. The last condition here is that this activity should be assigned to a single responsibility, and this is maybe the most important one, because when you develop a schedule, the point is to coordinate between the team. How you can coordinate between the team and put everyone accountable if an activity is just split between two parties in terms of responsibility. So you have to say that the rebar is assigned to the rebar fabricator who will be responsible for it. So if anything goes under performance, they cannot blame someone else. So 3 conditions for an activity to be called an activity is it has to have a discrete continuous duration. It has to be have a measurable quantity, so I can use it to track the progress, and also it has to have a single responsibility assigned to one of the project team members, subcontractor or a GC or even a designer. Then this is one activity. Once you have the activities list, the point is this activity list will be comprehensive and exhaustive representation of the project scope of work. Another thing we have also in the schedules are 0 duration activities, what we call milestones. And these just a different way of marking important events in the schedule. So I'm not tracking here the work, I'm actually tracking an event that marks a big thing happening in the project. So like a milestone can be saying that, you know, utilities are working, so I have utilities on site. That means that any activity dependent on having a utility on site for water or electrical supply, then they will know that this is where I'm looking for. So activities, milestones, kind of they together form your project schedule. Now, how you can actually develop this list of activities is you can use work breakdown structure. It's work breakdown structure is a visual tool. Again, we're dealing so far with a lot of visual things. Schedule is visual. WBS is also a visual thing. So WBS is a hierarchy of representation of the work. So you start with the building, and then you start breaking the building into work packages, and these work packages are broken further and further. So it's kind of a tree, but upside down tree kind of, and you start branching packages from packages until the level of detail that you think is good to represent the scope. And at the end of each branch is one of the activities in your activities list, and it has to satisfy the three conditions we mentioned before: discrete continuous duration, and then the responsibility, assignment of responsibility, and having a measurable quantity. So the benefits of doing a WBS is a very visual tool, so it simplifies the representation of a project. So if you get a project with hundreds of sheets and thousands of spec documents, going through these and developing this WBS, a very hierarchical kind of representation and visual representation of the project, it makes your life easy to communicate the scope of the project and coordinate it. And it decomposes now the responsibilities. So now me as a sub, I know I'm responsible for this branch or package of the work, and it's visually now easy to communicate. And then you can report now the performance of the project in the form of summary reports. So I can collect the data under one branch and then kind of lump this up into the head of the branch or the package that's, you kind of broke it down into tasks there. So you can identify the performance of each task, and then at the end you get a summary report or performance of this work package. One thing to pay attention to is WBS is like any visual tool. You can have multiple representations of the same thing. So I can represent it in a way different than you, but the point here is it has both of us representing the scope. We should have a complete representation of the scope. It can be like different angle of it, but it's still the same work. We're looking at it from different angles, but still it's the same project. So I can decompose now the project by project components. Like when you start breaking down the project, I can break it down by substructure, superstructure, and then you keep down component by component breaking it down. Or I can do it by the work materials type. So kind of you're following the master format way instead of the uniformat approach. So if instead of breaking it by substructure, superstructure, I can say Division 1 general requirements, Division 2, Division 3 concrete, and keep going by divisions, the type of work that will be done in the project, but as kind of lumping them together. So if I'm a sub responsible for the concrete or my expertise in concrete, then I will be just focusing on that block called concrete. This block can be spreading at different elements of the building, so like we'll have beams, columns, foundation, but me as a concrete person or contractor, I'll be more interested to read the project in this visual format rather than knowing substructure and superstructure and you go down this way. Or the third one, or the third way here of representing a project, it can be a mix. And actually the best way to have a WBS is you have a mix of both the project components or uniformat, and then you start breaking down by the massive format or work and material types. This is just an example here. So you have the building, it's broken down by site, foundation, and structural. And I'm breaking down further the foundation. I'm not saying that my activity here is just site and another activity is structural frame, because structural frame is like there is no quantity to measure it. So these two need to be broken down further, but I'm just following one branch and following one of its sub branches, just as an example. But this is not a complete WBS. This is actually an example of incomplete WBS. but I'm following here for foundation. I broke it down into you have to excavate, you have to do the piling, pile cap, and backfilling. That's for a specific project that has deep foundation. It doesn't have to be like that for other projects. For the pile cap, you have formwork, the reinforcement, and the concrete. Breaking down the rebar, then you have to prepare the shop drawings for the rebar, you have to fabricate them, deliver it to the site, and then install it. I can break further, but we'll see next in the slides, is this really worth it or not? But you see here, this WBS has here 5 levels. I can go deeper, but typically a WBS would be sufficiently describing the scope of a project between 4 to 7 levels. That would be a sufficient level of detailing in a WBS. Now, how far I can break down the packages and sub-packages and all of that. How do you know that this is enough level of detail? So the idea here, the typical kind of like in industry people kind of ended up or kind of a recommendation from practice is you decompose first by components. So you can start using the uniformat. So you have the structure, substructure, and different systems in the building, and then you keep breaking down by components, and then once you start switching mentally from describing that package and breaking it by activities or tasks like verbs, you use verbs, not deliverables, this is an indication that this is sufficient. You're getting closer to the sufficient level of detail. So as an example, one of the deliverables on the project is the component here is concrete footings. And then the delivery of that, to have a concrete footing, I have to have the rebar, I have to have the concrete, and for them to be done, I have to have formwork. So this is the 3 deliverables to have concrete footing. Now, once you see now I'm moving from rebar, I'm doing now verbiage description of how to get the rebar. I need to fabricate it, I need to install it. So now you're getting into actions or verbs. That's an indication that this is sufficient level of detail. I will stop this branch and breaking it down here. Maybe I'll break down other branches, but this is sufficient level of detail. So now you can see now this package here will have 3 sub-packages, and now there are 6 activities coming out of it. I will add it to the activities list. Now let's say I want to break down this further, removing and cleaning the formwork. And that entails all of this detailed list of other activities or tasks, or other called steps. So you take out the formwork, you move it to the cleaning station, you position the forms in the cleaning station, you wash the forms, you remove any debris in the forms, you coat the forms with the oil to protect it for the future uses, and then upload it or unload it and put it into the storage area. That's a level of detail that actually not necessary. It's just you're overloading your schedule with a lot of details. And by the way, like if you do that, you will end up with thousands of activities in your schedule, which is not recommended. It's always good to have a sufficient level of detail in the schedule that describes the project in the detail you want, but not in kind of the detail that kind of will be hard to control and track. So next thing, the next step here, actually covering this part, so we covered so far defining the activities, now how to estimate the durations for it. First thing is, if this work or this activity is being done by a sub, ask the sub. If you are GC, so you ask the sub. The second one is by experience. So if you can't get the feedback of the sub on activity and you really need to submit the schedule, then by experience, like this type of concrete work will take that amount of days or number of days, because you have seen this done in 20-30 projects before. If you have the data of these previous projects and you have the scheduled files of these, you can open them and say, oh, this work took 10 days in this project, 20 here, 15 years. So kind of you're getting a sense of how long it will take. But this is not accurate because every project have different conditions and different volume of work and all. So you have to pay attention to that. The most accurate way is using productivity rates. So daily output of a crew in a day, and you have this amount of work to be done, then you use the volume of work over crew production and efficiency formula as shown. Just pay attention here that this is typically ideal production rate that you get from your system in the company tracking system, or from RS means as a reference. But just use efficiency here wisely to account for any conditions on site that you want to account for. So we're done with the first two steps in the process of developing a schedule. You have to define first what are the activities in the schedule and estimate the durations of each one of these activities. So that's it for this video, and in other videos, the next two videos will cover the last three steps of the process of developing a project schedule. Thank you and take care.